Welcome to our webinar, Benchmark Validated Digital Thread Execution. My name is Brian Scouten. I'm the Director of Technical Pre-Sales at PROSTEP Inc. And today we're going to run through the use cases that we demonstrated for the A&D PLM Action Group's Digital Thread and Digital Twin Benchmark Initiative. For today's agenda, we're going to start with a review of the A&D PLM Action Group and the Digital Thread and Digital Twin Benchmark Initiative, and then talk about PROSTEP, PROSTEP IVIP, introduce the Digital Thread platform, and then jump into the use cases with the Digital Thread platform like bidirectional CAD integration, MBSC integration, collaboration with external partners, cross-system domain and impact analysis, and traceability and baseline with configuration lifecycle management. And then finally, we'll talk about the future of the Digital Thread platform and PROSTEP's organization and journey to that, as well as some AI enablement and other enhancements that we're making in the future. So let's introduce the A&D PLM Action Group and the Digital Thread and Digital Twin Benchmark. The A&D PLM Action Group was started by CIMdata as well as some aerospace OEMs and Tier 1s about 12 years ago, and they recognized that they needed a group in order to have common requirements, common processes and practices reflected from their specific industry into PLM. So the group then organized some research projects, organized different benchmarks and other papers like the one that you're seeing here in order to kind of provide feedback from industry and collaborate with the software vendors like PROSTEP in order to provide solutions for that industry. The Digital Twin and Digital Thread Solution Evaluation Benchmark that's seen here is available for free at the CIMdata website. And it catalogs some use cases about digital twin and digital thread across OEM, aerospace, and Tier 1s. It evaluates, what the current state of those commercial solutions are, and kind of sees that, there are existing commercial solutions like PROSTEP's and the digital twin and digital thread that offer some substantial practical value. As well as capabilities, and then also offers that there aren't all the solutions for maybe what you would want to see, and shows maybe some guidance on where the future is going within this type of industry as well. For those that aren't familiar with PROSTEP, we were founded in 1993 and really have been providing digital thread and digital twin solutions since then. You see on the right-hand side an old slide that we had. That's a product lifecycle management slide, but showed really kind of what we need to do is integrate these different domains and provide the kind of data continuity of that digital thread across the product lifecycle. And that was what it was in 1993. But today, in 2026, we're talking about digital thread and digital twin type solutions. Our mission is to be a trusted enabler of cross-enterprise digital thread integration. We lead with standards-driven integrations and secure data exchange and lifecycle federation. And we have a vendor-independent but multi-partner interoperability strategy that we do that with. So today, the PROSTEP group includes 5 different companies. The PROSTEP headquarters in Germany, out of Darmstadt, where they lead our product development, consulting groups, and others. PROSTEP USA, that's where I work out of, that supports the North American market and aerospace and defense initiatives here. PROSTEP Poland, that is a nearshore product development integration company. BHC, that supports consulting with about 60, 70 ALM and PLM integration and specialized software development consultants. And CENPRO CS, which is a joint venture of ours to support Airbus. On the bottom, you see the different companies that really make up our ownership. So each of these groups owns about 10% of PROSTEP, with the PROSTEP IVIP in the lower right-hand side owning about 15%. And we were really born out of the automotive market in Germany back in the early 90s in order to try and solve some of those data exchange challenges. So as I mentioned before, PROSTEP is a neutral vendor of integration within the engineering and manufacturing space. We don't resell any other specific software. We don't receive commission from other PLM vendors on software sales. What we want to do is be able to be a bridge between the different types of software and provide that interoperability. So with our technology partnerships, what we're doing is providing API and getting test systems and licensing those APIs so that we can build our technology of our connectors and our interfaces off of that and support that in a long-term availability. With that, then we can keep those connectors around and certify that they're tested and have that type of maturity across a long timeline for these types of integrations. So another important part of PROSTEP is kind of a core competency in interoperability. So we've got more than 250 consultants, and on average, they've been with PROSTEP for over 10 years, and many of them worked in other places beforehand. And they're familiar with multiple different systems because their interoperability always includes more than one. And the strategy, the processes, and the solutions for engineering and manufacturing. And focus on that type of interoperability for integration, for secure data exchange, and really dealing with really complex enterprise ecosystems. And together with the PROSTEP IVIP Association, which is a nonprofit sister company for the PROSTEP that deals with standards and in engineering and manufacturing, we kind of leverage that information and those best practices within PROSTEP in order to kind of have a good overall view for supporting interoperability with our customers. So the PROSTEP Group and the PROSTEP IVIP Association were founded around the same time. The PROSTEP Group that I work for is a for-profit services and software company that specializes in integration and interoperability and has been doing that for the last 30 years. The PROSTEP IVIP Association is in effect like a research and industry and standardization group that helps push standards through ISO or OAGIS or other types of certification bodies, and then also has like best practices and leading forums in order to better help interoperability in engineering and manufacturing. PROSTEP IVIP Association was started back in 1993. And that was initially working on the STEP 10303 AP214 automotive data exchange protocol to bring like geometry data together with PLM data so that automotive suppliers and OEMs could exchange it more efficiently. Since then, working on things like the code of PLM openness, trying to make the vendors of PLM systems agree to be more interoperable, smart systems engineering and digital manufacturing initiatives, and data-driven collaboration, software-defined products, and AI initiatives. So today, there's over 25 projects in the IVIP technical program. That includes the Codex of PLM openness, the PROSTEP IVIP ontologies, and the standardization strategy board, support for ongoing changes in the international standardization with ISO 10303, like AP 242 Edition 3 or Edition 4. ISO JT support, the OMG RecIF and requirements interchange support, OMG Cascade support, and then data-driven collaboration like digital twin and lifecycle collaboration, AI-enabled collaborative engineering, smart systems engineering, and other initiatives in order to provide interoperability, best practices, and standards within engineering and manufacturing. Let's talk about our overall PROSTEP offering. We have what we call our 3 pillars. On the left-hand side, you see consulting. In the middle, our software products. And on the right-hand side, specialized software development. Our consulting practice includes PLM strategic consulting, consulting on processes and methods, engineering IT consulting, as well as AI transformation. Our software products are encompassed by the digital thread platform that historically have 3 primary brands in it. OpenPDM for federation and integration, OpenDXM for collaboration and data exchange, and OpenCLM for traceability and digital thread. And then we have specialized software development, which is large-scale PLM-centric IT products for large customers that develop specific solutions that are necessary for their environment. Bringing together the 3 different pillars is what makes us experts. We're experts in engineering processes, we're experts in software development, and experts in overall interoperability and integration. The digital thread platform, what we're doing is not solving simple point-to-point type of integration processes, but for highly complex processes that involve multiple different systems, that involve the integration of that, data exchange, traceability, orchestration of the data across the entire product lifecycle. It's a solution for that, especially one that uses multiple different vendors for different types of solutions across the enterprise. Because we can leverage those different connectors and partnerships in order to kind of bring those all together and provide interoperability across all these different types of solutions and your engineering ecosystem. The PROSTEP digital thread platform has 4 core strategies it uses for interoperability, and these correspond to the different products and brands that are within the platform itself. On the left, we've got integration, and this is your traditional replication of data between systems. And export from one system, map it, import to the next. A lot of traditional integrations, like a PLM ERP integration, use this strategy where you might have a part and a bill of materials in your PLM system. You export that, you map that to materials and BOM, and you import that into your ERP. This is good in that it's consistent and you're keeping the data of the system. Sometimes there are mapping challenges to it, and it's more complicated than using a strategy like traceability because you have to map all the data and make it available within the other system. But it does have the advantage where the entirety of the system is usable, right? So if you're using CAD in your old system and you want that CAD to be usable in the other system, you need to import the binaries through the correct process to enable the CAD data management tools of that system to be utilized. A lot of what we do is integration for digital thread platform solutions. Second is collaboration, and this is like integration, except that it's across a corporate border. And so as a strategy, sometimes it uses things like neutral formats, and it has to really have a package of data like a digital data package that has all the semantic value of the data contained within it, so that the recipient knows, what the data is and how the data should be processed. So like I said, formats like Step 242 are prominent here. There's also other formats like the digital data package in general, PDF formats, other things that can be leveraged in order to do a good collaboration. And even sometimes proprietary formats, like native CAD data, proprietary exports are good here. Typically, you want to support a solution that's not one-to-one, but more one-to-many in this case, so that you don't need to scale out and to provide unique solutions for all your partners, but that give them something that they can use, that all of them can use, and be able to leverage that. Yeah. The third being traceability. Traceability is linking product data, typically using a web-like link, a URI or URL. Sometimes standards like OSLC can be applied here, and this is to develop a digital thread without replicating data. So when you trace data, what's nice about it is it's a very lightweight integration, in that all you need to do is maintain the link to the system, and then you can access that data at any time. What's good about it is that it's very flexible. You can draw data when you need it. You can write data back. What's bad about it is typically the system is one directional, right? Unless you write links in both systems. Where you're always accessing it from where the URI is contained. And also sometimes you lose some functionality, like I was saying before with the integration and handling data within the modules that your system is trying to leverage. Yeah. And the fourth is migration. And this is important in the digital thread platform because creating a digital thread as a strategy can be accomplished pretty easily if you've consolidated all that data in an activity we would call platforming. So bringing all those other PLMs you might have and then into a single PLM, and then be able to connect the dots and have all the capability and the data together within a single system, so that you can use that for your digital thread. The foundation of the digital thread platform are the connectors to the various vendor systems supported through those APIs and those technical partnerships. So what we're after really is the status data, the authoritative source of truth that's contained within the databases. So these connectors really go to repositories and aren't traditionally accessed through like a workstation client or manual type of process, but they could be, and in some cases are. The four supported use cases, integrate, collaborate, trace, and migrate, all use that type of technology. And also have common components within the digital thread platform that are used to support these various use cases, like an orchestration layer that has a BPMN workflow, a mapping engine. We have our batch processing framework that can be used for CAD translation and transformation or file and binary operations. We've got secure file transfer. We've got monitoring and processing of data. And we can combine all of these things together within the platform to have that best fit solution for the use case that you're looking to accomplish. So we'll get into some of the use cases now. We'll look at bidirectional CAD integration between different PLM vendors, MBSE and PLM integration, collaboration with external partners, and then we've got a couple of slides touching on this, but not a demonstration due to time constraints, on cross-system domain impact analysis and traceability with baselining and configuration lifecycle management. So the first use case is bidirectional mechanical design integration. And this is synchronizing the products and the CAD and other data between the different PLM systems. And doing that for a variety of different reasons. It could be that you've just got product components that are managed in different systems. Could be that you have a program that has an OEM requirement that needs to be synchronized with that different system. Could be that you have a merger or an acquisition that had a different PLM that went along with it. You never migrated, and so trying to bring those together. Or just having different management systems for design and production planning or other reasons. And others as well, right? There's a variety of different reasons depending on different customers. But what we want to do is enable that mechanical design to be used in the other system and synchronize it really back and forth so that you can use both systems effectively and use them for CAD design. So let's start with Windchill to Teamcenter synchronization. And this is automating the synchronization of data from Windchill into Teamcenter. So we've got a product in Windchill. We're going to open that product up. We'll show the Creo CAD data. And we're also going to initiate the transfer there with an action menu. Our Windchill connectors are going to export the parts and the BOM data with files and documents that are associated. And then our Creo controller will export the Creo data. We're going to map those parts and BOM and documents to item revisions and data sets, generate the STEP 242 data, JT data, and HTML CAD visualization. And then with our Teamcenter connector, import the revisions, the BVRs, the document data sets, the STEP, the JT, and the HTML CAD. And then finally, we'll show all that data in Teamcenter so you can see it within that system. So we're going to start within Windchill, and we've got our torque converter assembly. And this is both parts and Creo CAD that's associated with it. Maybe 30 parts in this assembly with multiple instances of nuts and bolts and things like that. We're going to open it up in the structure viewer, open it up in Creo so you can kind of see what the data is beforehand. And then initiate the transfer. And then after the transfer is complete, we'll show that within Teamcenter. What's going to happen behind the scenes when you initiate the transfer is that starting a process within the OpenPDM process server. That's a BPMN workflow engine, and what's happening is it creates an instance of that workflow that's configured specifically for this use case, the synchronization of data from Windchill to Teamcenter. So within the workflow, there's steps for getting the data from Windchill, like from the Windchill connector. It might be downloading the part data, the BOM data, the WT document data. It's using the Windchill CAD controller that has JLink technology that's exporting the Creo data. So it's doing things like renaming on export and doing it kind of in a proper Windchill way. And then it does some mapping. It maps that part data and BOM into item revision data and BVRs that are needed in Teamcenter. It's doing some translation of the Creo data. So we're going to take that Creo data and create HTML5 visualization, create step data, create JT data that we can then map into direct models and data sets and then apply those within Teamcenter. So that if you're not using a native Creo integration in Teamcenter, you're kind of getting the best available data that you could use. So this is good for something like a use case, where you might have two different PLMs within the same organization. You're using one for doing the design work within Windchill, and then Teamcenter maybe is downstream in manufacturing and production or doing configuration management within Teamcenter. Or maybe you're an OEM and supplier type of organization where you want to then publish the data into Teamcenter. Once you release it, and you want an automated way that you can then do that and collaborate with the OEM, and maybe also share kind of the design space going in the other direction. Like if you need to capture other systems that might impact your designs themselves. So we see that we got an email that the process was complete after we triggered it, and we're going to go ahead in Team Center and we can search for this. You'll see that there's a specification that was a WT document that was mapped over into a PDF data set. We've got HTML visualization here that we've generated, which has some nice features like you can explode the data. You've got the design tree that you can work through there. It's got cross-highlighting and supports PMI and attributes that came out of the CAD and other things like that. So this is nice for kind of a lightweight visualization within the web. You can also open that up in JT and then see the data within that kind of native Team Center format that you can also then use downstream within other Team Center applications. So if you want to use that data for manufacturing or some TC for sim analysis, things like that, then you can utilize that from the JT formats. And then after this, once we've completed this, we're also going to then showcase going the other direction and bring data from Team Center and then bring that into Windchill. And we're also going to show that within another movie in just a second. So the way it goes in the other direction, Team Center to Windchill synchronization, is we're going to start in Team Center. We're going to show the data there. That's the item revision, the BOM view revision. We've got JT, we've got NX CAD data. We're going to open the data up in NX and then initiate that transfer. Within the integration application, it's going to start that process that you see in the middle there, which will then trigger the Team Center connector, export the items, the BVRs, the attributes, the documents, the data sets, and export the NX through the UG clone or import-export utilities for Team Center. We're going to then map that data, map the documents, the items, the BVRs, the attributes to Windchill format. So go from item revisions into WT parts and then WT documents. We're also going to generate STEP 242, HTML 3D visualization as well for CAD data. And then we're going to import that within Windchill. So then you'll see the parts, the documents, and that structure there, and all the relationships. And then also Windchill, once it's been imported, will then generate the Creo view from the step. So that's going to use a Windchill CAD worker behind the scenes as kind of a post-process to the import in order to generate the visualization there. And we'll show that data, so the resulting data within Windchill that includes the parts visualization and step data, everything you would need in order to kind of have that synchronization into Windchill. So we start within Team Center, and we're going to then load up this assembly. Just like the last demonstration, we're going to open the assembly up and show the structure view, show the visualization of it, open it up in NX, and then you can then see the CAD data. And then what we want to do is then kind of, again, show the before and the after, but going in the other direction. So this is a seat assembly, and the seats, maybe 30 components as well, with a couple of levels of sub-assemblies that are used there. And we're also going to trigger it then from Team Center, and that trigger is going to then, again, trigger the OpenPDM process server that has a configured BPMN workflow that's going to then pull the data with the Team Center connector. It's going to pull the NX data with our NX controller for Team Center. It'll do the transformation of the data, mapping from item revisions and BVRs into parts and BOM and WT documents and things like that. It's going to transform the CAD data from NX into HTML5 and then also step data that will then be generated into Creo view. And then it's going to import the data into Windchill with our Windchill connector. So we can then load the data and then have that configured post-process in order to take the step data and then generate a visualization in Creo view from that. We have other, deviations from this workflow as well. Depending on what your use case needs are, this is not like a one size, one fit, one process. So if you would like to do things like I want to generate Creo from the step data, then you can go ahead and do that. That has an advantage of carrying over some of the structure. And we've got another demonstration that we're putting together right now that's doing that. So that you can then have the product structure available in Creo. Then from the EPM document structure, it'll map those to the parts, and then you can get kind of a good visualization. Not monolithic visualization, but component level visualization that will then kind of bubble up there. So we see within Windchill, we've got our part structures that have been created. We've created the documents as well within this, so that's step documents that we've published the Creo view from, as well as we've got HTML visualization that you can then open up from each of the different components, and then have that available as well for kind of lightweight representation, as well as the Creo view here. So again, these types of use cases, depending on where you want to do your designs, you can do designs and manage that within one system, and then automate the publishing of that data to another. This isn't exclusive to Teamcenter and Windchill either, right? So we have a lot of 3D Experience customers, or Smart Team, or other PLM or design data management types of systems that we support. Depending on what your needs are, we can do this between almost all major PLMs and work within that. So another use case that we demonstrated with the ADP-AG Digital Twin Digital Thread benchmark is MBSE integration. And this is really 3 different ways that you can integrate Cameo or Teamwork Cloud with PLM, ALM, or other types of systems. So the first one is our Teamwork Cloud integration. So Teamwork Cloud is a repository that stores data for MBSE and the Cameo client. So it's kind of that source of truth that you could then source the data from and status the data in for MBSE data. And we have a connector for that. So with that connector, you can then, just like you saw within the bidirectional CAD data exchange, exchange data with other systems. And the one that we're going to show today is a Teamwork Cloud and JAMA integration that deals with JAMA requirements synchronizing with Teamwork Cloud. The other 2, we also have demonstrations for, but we're going to kind of push that off because of time constraints. Using Cameo client plugin technology, so direct within the client, enabling you to then read and write data to a PLM system, or using the Cameo Data Hub, which has a OSLC consumer within it, that we can use our OSLC provider and a open PDM connector. In this case, it shows Windchill, but these could be any connectors because of kind of the neutral way that open PDM works, that you could then have a linked data type of integration with a Cameo specifically, because they have that consumer OSLC consumer technology. So in this demonstration, we're going to trigger the synchronization process, and that will then start the process server's instance of that BPMN workflow in the background. That will then export the data from JAMA, with the metadata, the files. It'll do the mapping, and then it'll import the data into Teamwork Cloud. And what we're going to have then is showing the requirements beforehand within JAMA, and then showing the requirements within Teamwork Cloud afterwards. So we're going to start this demo within JAMA. We're going to show the requirements structure that's within JAMA beforehand, so that when we open it up later, you can compare it to what's within Cameo and Teamwork Cloud later. We can also go into Teamwork Cloud and then show you that there's nothing that's currently available within that system, so that you can see that be populated later on. So we've got a small requirement structure for aircraft safety, just some demo data that we put together. In this case, we're going to show you some backend components. So the JAMA connector itself has an admin interface. This is intended to be an interface where you can, as an admin, go ahead and configure the connector. You can test out some of the functionality. So you can query the systems live, see what the attributes are, kind of go through the relationships of the data itself as well here. So this is an interface really just for testing out. And when you're doing the mapping and the processes, you can kind of gather some of the data within here. You can also, with this data model, understand a little bit better how OpenPDM works. So what we're doing is neutralizing that data when it's being exported into this intermediate format that then can be fairly easily, this object and relationship format, fairly easily mapped and translated between different OpenPDM components. And all the different services within the digital thread platform use that internal format. So it makes it easy to kind of move between services and then utilize the data, fairly straightforward, without a lot of different mapping, because it's all in that basic canonical format. So we can do the same thing within Teamwork Cloud Server, where you can see where the projects and the workspaces are, as well as with the model roots and the branches and things like that. You can see the attributes that might go to those, and that basic object and relationship model here as well. And so when we're doing the transaction and the process between the different systems, it's really just pulling the data out in that object relationship format, mapping that data, and then importing it. So specifically with this, when we're importing into Teamwork Cloud, what we're doing is defining stereotypes within Cameo that your organization already wants to use, like stereotypes for requirement structures. And then you can then go ahead and just define what that is, and it will import it into that format within the connector itself. So we started the process within the process server. This is just for demonstration purposes. And you can see the queue there, right? So the queue actually has a whole bunch of other transactions that have run there. So if you run into an issue with one of the transactions, you admins have a place to go, and you can see all the resulting data from that transaction, and then do things like restart it from the last step, or process the data again and clone the process and rerun it entirely. It also gives you neat things like KPIs. You can see the time that each of the steps took, and a lot of the time here is not in the translation of it, but in dealing with the export or the import and the systems themselves. It also gives you nice visualization of the data. So in that package there, that business object and relationship structure, we can visualize to kind of give you good view of what the data is, so you can better understand it. And that is before and after the mapping, and really each step generates some pretty detailed logs about what the process looks like. So we're going to go into Teamwork Cloud. You can go ahead and open that up, and you can see that the structure has been replicated here, where you've got different folders and requirements then, and you can kind of drill in and see what the different requirements then also look like here, and then compare that to what was in JAMA before, and see that the details and the descriptions have been carried over. So this again, a use case like this could be used where you're using JAMA as your authoritative source of truth for requirements, and you want to then port those requirements once they've been developed, and then develop those further within your system models that are within Cameo. So I can then take those requirements, automate the synchronization to Cameo, and then embed those requirements within the system models, so that you can then use what is the authority that's been developed within JAMA, and then process that within the models themselves later. In this case, we can also do updates to that. So, like in the case where you've maybe changed requirements, you can go ahead and see that there's been maybe some updates or a second synchronization of requirements there within these structures, just to kind of show you that you can do this in multiple stages and show updates or synchronize different data sets depending on what your needs are. All the use cases that we just showed right now use technology from OpenPDM Integrate. And that's the suite of different connectors, as well as the BPMN workflow engine. That's the OpenPDM process server. And that kind of gives you that neutral data as well as a workflow process engine that enables you to seamlessly connect different environments. So you saw today PLM, ALM, MBSE type of environments, CAD data, but we also do other types, MBSE type of environments, ERP, other things like that, depending on what your needs are, and integrate those with the process server, as well as the different connectors, to give you kind of a low code, no code type of solution for not just point to point, but using these in creative ways where you can do multi-system workflows, depending on what your business needs are. For our next use case, we're going to show external partner collaboration. And this use case focuses on when you have different partners that are entirely out of your network. So they have their own engineering environments, they've got their own product lifecycle management environments, and they want to then send you data through a managed file transfer that we're supporting here, that can then be automated into an import package. So you take the data that they've sent over, you analyze that data, you can then stage it within your PLM, and then a user could then come and then evaluate if they want to then import that data, and then what the import strategy might be, like if I need to revise data or create something new, or delete a BOM, things like that. Or you could even just have it automatically import, depending on your comfort level, really, of what the partner's import data looks like, and not do it in an interactive way, but just automate it. So go from just that digital data package that was sent from your partner and then totally automate all the import process, or have that interactive way. And we're going to show that interactive way right now. Within an import from an external partner into Windchill. So we'll start this demo as the external partner that has the data that we want to send to, let's say, an OEM in this case. So we have a Creo assembly. It's got maybe 30 parts to it. We're showing that now. And we've got the files that are available for that Creo assembly. And we want to then send those files to the partner so that they can automatically have them available within their Windchill system. So we log into the OEM's provided OpenDXM Global X portal. We assign that to a recipient. Now, recipients then have different options, and they can have maybe a single workflow, or you can have different types of workflows that are associated with that, so you can process the data correctly. And that could be, I want to determine what my import strategy is, like depending on what my use case is. Maybe I have a change use case, or maybe I want to have a review use case or something like that. You can kind of tailor those. You can do import prognosis, so you can do an evaluation of the data before it's directly imported. You can do translation workflows. So if you want to take this data not from Creo to Creo, right, what's happening here, but maybe I'm going from NX and I want to bring it in as Creo. Well, we can have that automated workflow in order to do the translation as part of these processes as well, and then import the data, kind of like we showed within some of the previous demos. You then write a message. This is going to be sent in an email, and then also automatically updated and uploaded into a container within Windchill. So the whole transaction history of the data that's been sent over will also be contained within that Windchill. So you'll have that as reference, as kind of a what happened, when I was sent the data, and then when I imported the data as well. So over in Windchill, we've logged in there, and we're taking a look at the assembly data that exists today. So there's one that Richard Schmidt's been working on. This is version A.2, and then I want to go ahead and take a look at what's been sent to me. So we've got our OpenDXM Global X integration to Windchill deployed here. So within the data exchange product that we're using just for the demo, you can see that there are these Global X jobs. These Global X jobs are actually just subfolders that have a neat little PROSTEP icon. And there's ones that are sent out from the system, so you can actually package data and send it from the system automatically, and ones that have been received, so import tasks. And from there, you can see that there's been multiple import tasks. You go ahead and select one, and then from there you can also see what the data is, so it'll create WT documents of what that data is. It'll also show the data in the files, or a zip package or a digital data package of what needs to be imported then. This gives you a way to kind of stage the data, and you don't want to always just automatically import data from a partner, because you don't know if it's the right data, or maybe I don't want all of it, or maybe I want to reject it because it doesn't meet the criteria of what I want to do based on the evaluation that I'm making. So the wizard here that pops up will show you the status of the data. In this case, you already have version 2 of the data that exists there, so you're going to be updating that data to version 3. It'll show you the different files that are within the Global X transfer here, and that could be part files, it could be WT documents, and in this case also Creo data. It's generating that HTML5 visualization, so you can take a look and evaluate the data. You can do things like take measurements here, explode the data. Do other neat things, look through the attributes of the data, make sure that it's all up to your standards before doing an actual import into Windchill of what that Creo data is. You can then reject it and say, I'm not going to import this. It'll send an email back to the originator Or you can validate that, yes, this is ready to import, and then click that Start Import button. So once that has been clicked, what's going to happen behind the scenes is we're going to use our Creo CAD controller, and it will then take this zip of the digital data package of the Creo data and actually import it into Windchill. And so what the net result of that is the Creo data will be updated within Windchill, and you'll go from the version 2 that you had here, and then after it was updated and after it runs for a second, be updated into version 3. And this is happening asynchronously behind the scenes. It sometimes takes a little bit of time in order to process the data, and import it through Creo, and probably a minute or so for this small assembly. So now that we've processed the data, we see that it's version 3, and we can see that it's been updated just then, and to version 3. We can open up the structure of the data and then take a look at that as well, and see that all the data has been updated, not just the assembly component right here. And this shows you an interactive import from a partner that's provided data in kind of a real controlled way, and how to collaborate with data from external partners into your PLM environment. So this process was done with our OpenDXM collaboration environment. This works also as an export. So in fact, one of the original demos we did was not an import demo, but an export demo that showed data being collected from that environment, like a Teamcenter environment, packaged up and then sent to a recipient. And so it's bidirectional in that kind of collaboration. But it enables you to have all the logs and traceability of what these transfers are, do regulatory compliance of that data, understanding where it came from, doing it a high level of encryption, and then maintaining that continuity across your border of the digital traceability of where that is with all the transaction history, and also enabling the import and export. And doing it with a file-based and metadata-driven type of integration. And this doesn't work just for Windchill. We've got connectors for 3D Experience, for Teamcenter, for SAP as well as direct integrations for all the other types of connectors. So if you want to have something that's entirely automated between the two different environments, then we can help with that as well, not just manual on one side with the portal. That gives you kind of a many-to-one type of solution. So it's a way that you can automate all of your providers of data, right? But if you want to have a bidirectional one, we can do that as well. So because we got limited time, we wanted to just introduce the other use cases shown in the ADPAG benchmark, but we don't have demonstrations, unfortunately, for them. One of them is OpenCLM traceability. So OpenCLM is a system that sits on top of all those integrated connectors and then can provide cross-domain and cross-system traceability by linking data into those different systems, and then creating a configuration lifecycle management, creating baselines. You can do impact analysis. So if you've got validation results or test cases or requirements, or other types of things, even product data or architecture, you can bring all those into OpenCLM and then do an impact of what a change of requirements might be, because all the data is linked in there. Take a baseline, right? So understanding what the maturity of the data is at that point in time, right? And then the evolution of that can also be shown within OpenCLM, as well as doing things like exporting that data in a digital data package, and other neat use cases. And then finally, we've got OpenPDM Migrate. And this is a system to do migration across different vendors, right? So I want to consolidate data into my platform that I'm going to use for the digital thread. And systems like 3D Experience and Teamcenter and Windchill are good at handling that. So in order to get the digital thread all combined and understand the traceability, you can use those systems and the modules within them for handling it across the entire product lifecycle. Is a very valid mechanism for accomplishing your digital thread. So what we can do with OpenPDM Migrate is take those legacy systems and then load that data into your platform that you want to use. And we can do that either in an ETL approach. So if it's a small amount of data and you want to do it over a weekend, then we can do that. Or we can do it in a large scale approach, transactionally with a coexistence style incremental migration. If you can't move all your users at once, typically that is a right strategy for doing that type of migration. And finally, we're going to talk about the future of the digital thread platform and what our journey has been so far to try and create a unified platform of all these services. And then in the future, how we're using AI enablement and enhancing connectivity to these different systems. Historically, PROSTEP has had different brands, OpenDXM, OpenPDM, OpenCLM, and we're in the midst of transitioning that to the digital thread platform. And we're doing that because really there's a lot of overlap between the different components, and we want to be able to have kind of a unified ecosystem where you can plug in the tools that you need in order to get your use cases accomplished. So in 2019, we adopted a standard microservices underlying architecture for every component. We changed around product development. So we have architects that aren't just focused on a single system, but on the whole ecosystem. And then, also the pool of developers is focused on the entire ecosystem. We're ensuring there's a compatibility for SaaS and iPaaS. And we want to do this so that we can meet customer requirements that might not be fulfilled by a single product, but really kind of a combination of the different technologies and services that we can plug in. Today, the digital thread platform looks a little bit like this, where you have standard stacks of OpenPDM, OpenDXM, and OpenCLM, and there's interoperability between those because of the foundation is similar, and they all share system connectors. So where is the digital thread platform going in 2026? What we're doing is adding a knowledge management graph and ontology definition layer. So data that's pulled out of the system connectors will be persisted within the knowledge management graph, and you could do an initial load of all the data if you like. And then you can define your ontology so that each of the systems that are connected then will speak your enterprise language. And then from there, we then have tools that you can use, such as MCP, direct tool calling, direct chat as well to the knowledge data there, so that you can query and use this type of ontological service to pull data out of your systems, and then have more AI functionality within the integration in the digital thread platform. Thank you for joining the webinar today. If you're interested in more information, you can go to www.prostep.com, or you can send an email to infocenter@prostep.com. That's the best place to go. They can route you to the right people, tell them what you're interested in learning, and then they can give you the right region and the right people in order to get you an answer. Thanks again for joining. I'm Brian Scouten, Director of Technical Presales from PROSTEP Inc. If you want to, reach out to me as well, brian.scouten@prostep.com. And appreciate your time today joining the webinar.